So, and this will be negative y to the third over x to the third. They're asking just to find dy over dx. We're not asked to differentiate, to evaluate. So this is it. So if a quantity has a negative exponent and it is in the numerator, it will come down with a positive exponent. If a quantity has a negative exponent and it is in the denominator, it will go up with a positive exponent. Very good pick. Thank you.
Did we do number 55 on that same page?
Yes, 55.
That's going to be on the test.
Yes, but this is the second derivative. So this is d2y over dx2. Okay? So you said 55, so x squared minus xy. And plus x squared. No. Sorry, this is y squared. And plus x squared equals 5. Is this the one? Did I copy the right one? The one you wanted?
Oh, yeah.
Okay, perfect. So first we have to find dy over dx. And then d2y over dx2, the second derivative. Okay, so let's do that. So this is the function. How do I know? It's very clear. Second derivative of y with respect to x. So this is the function, and this is just the independent variable. So we differentiate both sides. So this is 2y and dy over dx minus, so this is the product rule on this. So leave the negative outside. The first function prime, that's the independent variable, is 1 times the second function plus the first function times the second function prime. So this is dy over dx. And this is simple, plus 2x. This is very simple, 0. I have to distribute a negative sign. So this is 2y dy over dx minus y minus x dy over dx plus 2x equals 0. The variable is in two quantities, which means I have to factor out. So I have 2y minus x, and I factor out 2 dy over dx equals 2x will move to the other side, y will move to the other side, and automatically change the sign. That's it. So this is my dy over dx. dy over dx equals this over this. Y minus 2x over 2y minus x. Okay. So this is the first derivative of y with respect to x. I don't recommend trying to find d2y over dx2 from here. I think you should go back here at this level, at this step, and find the second derivative. It will be easier. So, and no, the answer, once you ask for a problem, I have to finish it. But no, I will not ask you to find d2y over dx2. But let's continue, because you're asking, so I have to finish this. So this is again the product rule. And this is again the product rule. Okay, so 2 stays outside. First function prime, dy over dx times dy over dx, I will have dy over dx squared plus y times this function prime. Well, that will be d2y over dx2. So I'm done with the derivative of the product. Minus dy over dx, because I have to differentiate, minus, in parentheses, first function prime is 1, and then dy over dx, plus x times the second one prime, d2y over dx2. And then plus 2 equals 0. I had a professor at the 600 level classes in which he would say, oh, this is messy, you do it. Why can't I do that to you? I know it's messy, but I just can't say that. So then I have 2 d2y over dx2, and then plus 2y, wrong, I talked too much.
Question?
Yes?
When you do dy over dx minus, and then you write minus dy over dx, that's still a negative, right? It's not positive?
Correct. So the reason I put something here, if I didn't, why would you look at the next row?
Okay.
If I don't put anything, how will you know that this is connected to what follows? You would say, oh, that's done. But if I put something, then you're going to look for continuing process. If I don't put anything, you may say, oh, it's done. But no, it's not a double minus. This one says, look for the next step, and it continues here. It's like when we get to the end of the row and I want to write, I don't know, government, right? So it tells you that something follows, that I haven't finished. So this, I guess, not everyone uses that concept, I guess. So I don't know. No, it's not. Very good question. It's not a double negative. It doesn't change into positive. It only says look for the next step. Okay, so so this is dy over dx squared plus 2y d2y over dx2 minus dy over dx, and I of course I got over my, so what I'm going to do, I'm going to continue on the next page. And you know that that minus doesn't have a double minus, but I just made a mess. So I have to move on to the next page. And this is not working now. Okay. So minus, where am I? Right here. So dy over dx, and then minus dy over dx, minus x d2y over dx2 plus 2 equals 0. Okay, where is my variable? This is my variable. Everything else has to move to the other side. So, and 2y minus x, d2y over dx2. This will go to the other side, so negative 2 dy over dx, but that is squared. This is negative 2, so it's positive 2 dy over dx, and this will be negative 2. So one more time, 2y with minus x, yes, that's correct. This goes to the other side. This combined like terms goes to the other side, and that. Okay, finally, I shouldn't say finally because d2y over dx2. So negative 2 dy over dx. Again, I'm not testing endurance, so you're not going to have to do that. And 2y minus x. But now, I do have to replace dy over dx here and here with what I found on the first step. I'm just going to put it in, and I'm going to say like my ex-professor, I never liked that person as a teacher. Okay, so I'm going to say like he did, you take it from here, it's messy. No, I can finish it up. So what I would have to do next is find the least common denominator and multiply, and the least common denominator will be 2y minus x squared. So this is negative 2 and y minus 2x squared plus 2 and y minus 2x and 2y minus x and minus 2. There's a lot of algebra here. And 2y minus x squared. With your permission, I will write etc. because It will take me a while to, it's not difficult, it's just that I have to multiply a lot to find the second derivative. You will only be asked to find the first derivative. So here I will have to square, distribute -2, multiply these two, distribute 2, square 2y minus x, multiply by -2, combine everything like terms, and this is, I'll flip it into 2y minus x to the third in the denominator. So from this moment on, it's just plain algebra. Is that good enough? Do you want me to continue the algebra?
You don't have to continue if you don't need to do it for the test. Thank you.
No, it's just, this is just a test in endurance of algebra. So you're only going to be asked to find dy over dx, not the second derivative of that function. Okay, next question. What would we like to look at? Anything from limits, chapter 1? Anything else from chapter 2?